So today I'll be reviewing the USACO 2017 January Contest Silver Problem 1 Cow Dance Show. So I solved this using Python, and I'll go over how I solved it. So the question is, after several months of rehearsal, the cows are just about ready to put on their annual dance performance. This year they are performing the famous bovine ballet Cowpelia. The only aspect of the show that remains to be determined is the size of the stage. A stage of size K can support K cows dancing simultaneously. The N cows in the herd are conveniently numbered 1 through N in the order in which they must appear in the dance. Each cow I plans to dance for a specific duration of time Di. Initially, cows 1 through 7 appear on stage and start dancing. When the first of these cows complete her part, she leaves the stage and cow K plus 1 immediately starts dancing, and so on. So there are always K cows dancing until the end of the show, when we start to run out of cows. The show ends when the last cow completes her dancing part at time T. Clearly, the larger the value of K, the smaller the value of T. Since the show cannot last too long, you are given as input an upper bound T max specifying the largest possible value of T. Subject to this constraint, please determine the smallest possible value of K. So the input is the number of cows and then the maximum amount of time that the show can run. And then the next N line gives each of the cows and how long they are going to be dancing. And then we're printing that the smallest possible value of K, which is the smallest number of cows that can be on the stage at once, for the show to not go past T max. So it is guaranteed that if K equals N, the show will finish in time. It's just saying that there's no outliers. Okay, so let's try coding now. So first of all, I'll get the input by using N and M. N is the number of cows, and M is the maximum amount of time. So I'll do int of I for I in input. We have to use the files later, but for now I'll just do this. I can fix that after I run in the console and check that it works. So I'll be saying int of input for n times. Okay, so I got the input now, and we're going to be using binary search. Basically, the least amount of cows that can be on at once is 1, and then the maximum is n, right? Because our answer is going to be some number between 1 and n. So I'll be trying to solve this using binary search. So L and R is going to be our left and right bounds of our answer, 1 and n. Okay, so I'll use the normal binary search for minimum values. So mid equals L plus R divided by 2. If I'll be making a function to check if this mid value actually works. So if this performance works, then R equals mid. So I'll move the right bound down because I know that a number below it might work. And then if not, then I'll move the left bound up to mid plus 1. And then I'll be printing L as our answer. So what we need to do now is just make the can perform function. So I'll get an input K, which is our mid value here, checking if that K can be our answer. We're not checking if that's the minimum, but we're just checking if this works. So I'll make a stage using a list. So a thing that could work here would be a sorted set, but we can't really use that in USACO problems because they don't allow that. So instead, I'll be using a heap to get the smallest value below our already set K. So basically, like when one cow is done, then another cow is added, we're going to get the smallest value for which this works. Okay, that might not make the most sense, but follow along with me. I promise it will later. So for num and nums, I'm going to go through each of the cows, and if the length of the stage is less than K, so if we can keep adding, then we will just be adding our current cow to the stage num. And then if not, so if the stage is already full, the earliest that we can add it to is hipq.heap_pop stage. So this is the minimum value, and then so that's the first one that's going to be done on stage. Then hipq.hippush stage So we'll be removing the one that ends the earliest and then adding our count currently after it. So then we'll be returning max stage less than equals to f. So the max stage, it basically means the time of our whole show. If it's less than equal to m, that means it works. So we're returning the true or false here. Okay, so that's basically it here. Let's try with our sample input. Okay, so it worked. Instead of this, now I'll be changing it to the file cowdance.in and cowdance.out. So in the beginning with open cowdance.in rsf, this is just how we get the input. And then instead of input, we use f.readline. Okay, and then same thing with our output. We'll do with open cowdance.out w as f.write string of length, string of L, and then n. Oops, so n here. So we're adding an enter after it. Okay. So I'll try submitting now. And it worked. Okay, I hope this helped and thank you for watching.